Hello friends, let's start the decarboxylation reaction in this video. Let This is reaction number 8. What is decarboxylation reaction? So what is decarboxylation reaction? Decarboxylation, in the name, the reaction is hidden in the name. Decarboxylation means removal of what? Carboxylation means CO2. Removal of CO2 gas. So here, what is the substrate? Here any acid, carboxylic acid can be, and reagent is used as soda lime, NaOH plus calcium oxide is heated to give simple alkane plus CO2. But if you see here, CO2 is evolved in the form of calcium carbonate instead of CO2. Calcium carbonate is formed here. So what is the direct matter of the reaction is that simply if soda lime is given and heat is given, then simply suppose any acid, let's suppose benzoic acid is there, simply remove out this CO2 group and attach this hydrogen to that carbon. So what will be formed? Simple benzene will be formed. So this is the direct method of that reaction. Now let's, without any delay, comes to the mechanism of this reaction. What is mechanism? First, what is happening here is that, let's suppose here acid is here, basic medium is there, NaOH, acidic hydrogen is there, it will accept proton from acid and what will form? C double bond O minus, Na plus plus, water will be formed. Sodium salt of acid, carboxylic acid. Now what will happen here? After this salt will react with, if heated with in calcium oxide in presence of, what will happen? This negative charge will come here and this negative charge will go to carbon of that alkane, and simply REH plus CaCO3, calcium carbonate is formed. So this is a simple mechanism, but in exam mechanism will not be asked. Simply direct reaction in any sub question will be asked. Now if you see, this is decarboxylation is a very slow step, and this is the RDS, that is rate determining step of that whole reaction. This is the rate determining step. It is depending on, here negative charge is formed on that carbon of alkyl group. If this is more stable, then this will be the gives easily decarboxylation reaction. So now let's compare the rate of decarboxylation. If I draw here three structure, COH, NO2, here also COH, NH2, and here simple benzoic acid. So which will give very fast decarboxylation reaction is that, let's suppose I marking it as ABC. So here electron neutron group is there, negative charge will be formed here, and this will be well stabilized by benzene ring as well as minus M of that NO2. This will give plus M, and this negative charge is little much less stable than compared to this, and this also due to plus M effect of NH2, and this is intermediate stable between these two. So what is the rate? A, C, B. So this is the rate of decarboxylation reaction. So now comes to one question, I will give you that for practice only. Let's PSCHO. What is this? Benzaldehyde in presence of NaOH. What will be the product? A plus B. Two products are formed. I think you may get the hint of that reaction. What is this reaction will be happen here? If you see base is used here, alpha hydrogen is not present, then which reaction will be occurred? This is Cannizzaro reaction. And in Cannizzaro reaction, what is the product? Let's suppose A, what will be the A? Let's suppose one is the oxidized product and one is the reduced product. This will be PHCOO Na, O minus Na plus, and another B1, what will be the B? PHCH2OH. This will be the product. But whole question is A on in acidic medium gives C, which on further in presence of NaOH and CO give D, and B on alkaline KMnO4 gives E, and which on further NaOH CO gives F. Then what are the D and F product? We have already seen that what is A and what is B. A is salt of benzoic acid. So after in acidic condition, what will happen? This will converted to, in presence of acid, this will convert to simple benzoic acid. And in presence benzoic acid, I write here, I am writing here benzoic acid. What is the structure of benzoic acid? C double bond O, OU minus. After reacting with base, what will form? C double bond O, O minus, Na plus. And if we heat it with calcium oxide, what will be formed? Benzene, simple, and minor calcium carbonate will be the byproduct. What will be the F product? That comes to the F. So here if you see, our B product is benzyl alcohol. What is the structure of benzyl alcohol? Here benzene, CH2OH. After reacting with alkaline KMnO4, this is the very strong oxidizing agent. This will convert benzyl alcohol to simply benzoic acid. So now the next step is, we already studied here. This is depend on that decarboxylation reaction. If you reacted with NaOH plus calcium oxide, that is soda lime, heated, then it will simply give benzene. So both our D and F are products same. D is equal to F. Therefore both products are same. So this is the decarboxylation. In previous year, no in a directly question asked will depend on the decarboxylation reaction, but in mains, JEE mains, some sub question means, let's suppose one reaction is given lengthy reaction, let A gives B gives C gives D gives F. This type of reaction will be if asked, then some one step will be based on decarboxylation reaction. Now another point is important in that reaction is that, let's see here, in case of, let's suppose, this type of structure you have see anywhere, then if any base is also not used, then there is no requirement of soda lime. It will simply decarboxylate and it will be converted to aldehyde plus CO2 gas, because negative charge, sorry, not this type of structure, I missed one carbon here, is that beta keto carboxylic acid. If this type of structure is present, then there is no requirement of soda lime. It will simply decarboxylate to give ketone. Why this will happen? Because negative charge is formed here. If you see here, negative charge will be negative charge will form on that carbon. So this will be more very stable due to resonance. So it will simply give decarboxylation reaction. And if you see here in the decarboxylation, what is the driving force of that reaction is that driving force of that reaction is CO2 gas will be removed and entropy of the product will be increased. If you see in thermodynamics, I hope you have learned it already. We can say the reaction is spontaneous if the entropy of the reaction is increases. So here entropy of the reaction is very increases because CO2 gas is removed out. Therefore this reaction, this is spontaneous reaction, and this is the driving force of that reaction. I hope you have will understand this reaction. And please remember this type of structure. What is the structure I am writing again here is that beta keto carboxylic acid. If you see anywhere this type of, sorry, I am writing neatly here, CH2 beta keto. This is alpha carbon, this is the beta carbon, and if any carbonyl group on beta carbon, then it will easily decarboxylate to you ketone. So I hope you will understand that decarboxylation reaction, and I will continue the next name reaction in the next video. And thank you guys.